Go to assignment 2. Now, in assignment 2, you are going to deal with objects with moving parts. You are going to be creating a design with moving parts. In this example, we begin with something that exists physically. Note that this is a special case. In your designs, you may be dealing with an idea that exists only in your mind, and a rough hand sketch may be necessary. In the assignment for the next 3 weeks, use a piece of furniture or any other artifact that contains moving parts. Then you can measure dimensions and implement the model directly. I keep showing you my chest of drawers because that is one thing that I have already fully modeled and I've given you. And some components allow relative motion. Some motions are transmissible, like you use the slider to move between the drawer and the body of the cabinet, whereas handles are fixed rigidly to the drawer. So all these things are ideas that you can also implement in your own homework. Now, an example of transmissibility is the motion of the slider. It can transmit motion between the body of the cabinet and the drawer. The two are not touching each other, but each of them is touching the slider, and therefore their relative motion is enforced by the slider. There are other examples. There is a reciprocating saw example, which is in the Autodesk mechanical assembly example that I will lead you to shortly. So there are up to 10 or 14 videos that are incremental that you can watch on that reciprocating saw, and I think you should go to look at those videos. Let me run a session of Fusion 360 so that you can see. Now, if you want to see the example of the reciprocating saw, that is not my own example. It's an example by the product manufacturer themselves. You go to the help menu, which is the question mark near your personal logo or your initials or whatever icon that you have on your own Autodesk Fusion 360 installation. If you click this help, the next thing is that you have a drop down, and the second thing on the drop down is learning and documentation. So you can go to learning and documentation. If you click on learning and documentation, from here, you click on learning and documentation. One of the things there is self-paced learning. So you've moved from help menu to learning and documentation, then to self-paced learning. So click self-paced learning. Immediately you click self-paced learning. You are taking through your web browser to a page that has the self-paced learning fundamentals of Fusion 360 that are on a particular page together. So you have the Fusion 360 fundamentals, 3D modeling, assemblies. So that third list on the left hand and the right hand side, you have mechanical assembly fundamentals, and there are 14 videos there. So if you click on that mechanical assemblies fundamentals, you will see this reciprocating saw, and that's an example that I want you to take a look at, and then use that in conjunction with the slider motion of my drawer cabinet to motivate your creation of your own design that you are going to submit for your example. I have already given you the full file or you can go to the website. The full file of my is now available to you, so you can download that, and then you can see how I made each of those components into that assembly. That you can see that in that assembly, all the filing cabinets, all the drawers are moving. The door, there's one of the cabinets that has a door that rotates with a handle that has a rotatory motion in opening. So what I want is anything you can do. Don't just give me back my own drawing. Go get your own done and give it to me, but make sure that what you are submitting has the same level of complication or difficulty as the one you are getting. But you are not limited to the kind of motions that we are giving you. So we are going to implement your motions using the joints and all the other things that you are seeing in the examples you are being given here. So that's what I want to talk about in that one. So let me put this down, and then we can go back to our slideshow. So in addition to the cabinet, we have looked at, watch the videos, I think the videos on the mechanical assembly provided by Autodesk. And I've guided the class to the location of these videos. So if you don't know where the videos are, I've told you now. And then the slider, this is just something that you've already seen. I'm just showing you an example of this slider, which is already fully with you in that you can download. So assignment 2, with these 2 examples, create a design with at least one transmissible moving component. You are going to get marks depending on how realistic and complicated your final result, your final submission is. If you do something very trivial, then you get a trivial grade. You can copy ideas. But not the drawing directly. Don't be lazy. Copy ideas, but don't copy everything hook, line, and sinker. Don't just give me back or just take what the Autodesk people have done. Make your own dimensions and design. They can be existing objects that you measure or ideas you create. This one, the due date is May 8, 2023. Again, it is worth 10 marks. 5 marks penalty for up to 2 days late submission, but once you are more than 2 days, 0 for the assignment, but still complete the assignment for the final examination as before. I will give you a 3rd assignment before the end, and that 3rd assignment is going to involve the application programmers interface. So we are going to start today learning about the application programmers interface. But before we go, just remember that you have been given the Faculty Day complete drawer cabinet in Fusion 3 file that can be downloaded. Theodos get mechanical assembly. I've told you how to navigate to that. And then, so before I now move to today's work, which as I've told you, is I want to see if there are questions about the assignment and anything you need to know. So please, can you go to the chat room and let me know if there are issues you want us to discuss concerning the assignment. Earlier, there are 2 assignments that are compulsory to be. Whatever assignments I gave you before, these are the 2 that will be given grades. So these 2 are not only going to be given grades, you must bring them to your final exam because you can be examined on them. Will be rated. There is a 3rd one. The 3rd one before the final. So that will therefore be 3 assignments in total. So Elon Akin Onitolo, I hope you are clear on that. Any other question? Please, what's the format for submission? Submit in F3D. Any question for that? You are supposed, I keep giving you videos to watch, my own videos and the Autodesk videos. You cannot go wrong by watching too many videos. There are so many videos there, and their own videos are really great because they are very specific and they are made by the experts in the company. So I really like those videos, and they are better than most other ways you can learn the software. But I tried to make sure that my own videos do not just repeat what they have done, so that you can also learn more. But my videos are not alternatives to theirs. You should use their videos and then get the knowledge to be able to follow the kind of things that I'm doing on my own. Like today's work now will not be in many of the Autodesk videos. We are going beyond what Autodesk teaches on the Fusion 360 help system. So So what we are going to be talking about today assumes that you have already gone through all their videos and you have basic skills. I want you to have those basic skills and then advance. It is not a bad idea for you to develop yourself and go and take their certification exam. And the more members of this class that have that certification, the prouder I am about you. I will be proud of you. If you not only come to class, you take the extra step to improve your skills and be certificate and get a certification for being able to do that. But I want to explain to you the difference between getting a certification in Fusion 360 and getting through an engineering degree. Both will give you, if you do both well, each one can give you your daily bread. You can get your daily bread by being a certified Fusion 360 user. And but the goal of a university degree is different. In the university, we are trying to use the graphics design to teach you engineering. So the graphics design is not an end in itself. We want to use it to show you how the equations that you are deriving in your mechanical courses and relate to making a product. The Autodesk certification process does that. But it's not that it can't do it, but they have a large, somebody can be in secondary school and be certified. Somebody may not have any interest in fluid mechanics or mechanics and can be certified. But you are in a university and you are in an engineering program where you are being taught other things. What we are trying to do here is to use the graphics as the center of your learning engineering. Therefore, our goal goes beyond what the goals of the certifications are. So the fact that somebody is certified doesn't mean that they are satisfied and fulfill our own goals. We are not talking of what is better now. It's not a question of one thing better than the other. It is that our goals are different. There is nothing stopping you from excelling in both goals and then choosing when you are now working to see whichever one of them you now want to use to earn your daily bread. But our goal here, I am not here to show you how to get certification from Autodesk. That is not, you don't need to come to a university to be able to achieve that. So I'm not saying that is therefore lower. It's not, but that is a different thing. But if half of the class can go and get that certification, I will be so glad. So do whatever you can, get certification, get skills. The more skilled you are, the more I can teach you the other things that I want to, that are good for your degree and for your other training. So I think that is clear and that is delivered.